Welcome back guys. So in this video I will talk about how to write a function for other use cases. So let's say you have a requirement where you need to write a function for a string which will do a conversion of your string to the uppercase, and then it will do concatenations with some other string. So how do you write a function for that, right? So we have something called functions. So if you look at here, this functions is the functional interface. It's a part of Java util package. Okay, it's a part of Java util package, and it takes two argument, like what is your input and what is your output. Okay, so this is your input and this is your output, and let's say write add a string is equal to. So what I need is, I have one input a string which is nothing but, let's say, name. You can give any name, it's up to you, right? Arrow mark, and then whatever string you have, dot convert to uppercase, dot concat to, let's say, Ram. Okay, so this is your function. So these functions, what it will do, whatever you will supply the input, it will convert to the uppercase and it will do a concatenations. But before that, we'll try to understand what is function. So just press Ctrl, click on functions, go to the source code. See, this came as a part of Java 1.8. Represents a function that accepts one argument and produces the result. You can look at here. Represents a functions that accept one argument and produces a result. What is the parameter to this interface? Two parameter, T and R. What is the T and R? The type of input and the type of result. Like what input you are supplying and what result you want, right? It has a method called apply method. So internally, whenever you write a function, internally it will call this method apply method. When you perform the actions on it, internally it will call this apply method, and it will give you output as a R. So the R is nothing but the type of result of the functions, right? It also has some more method called compose. You can see that there is a other default method. So why this interface is the functional interface? Because it has only one abstract method. The other methods are default, which also came as a part of Java 8. So you can write the default method in the interface, and you can write the implementation. So this guy will make sure that your existing implementations of interface, whoever is implementing it, will not break that, right? Because this is default. So you can write the implementation. So you have another method called compose. We'll see that how this works. And then we have something called and then. So and then basically you can club multiple functions and you can get the output. I will show you through examples so how this and then will work. Okay, you can read through Java documentations whenever you have a time. Okay, so and this and then means it will combine the multiple functions, like functions 1 and then functions 2 and then functions 3 dot apply. So apply is the one which will perform the job, this guy apply, right? And then you have something called identity, right, which also we will see that, like how these all methods work, right? You can do that. Control O, it will list out. Basically you have four method: apply, compose, and then and identity to this functional interface functions, right? So this is the first one where it is taking one argument, okay, and it is converting to uppercase, and then it will do a concatenation. So let me make a main method quickly. Okay, and let me make this static so I don't need to create the object of the class. So now we have this function as a static. Straight away in the same class I can write like this: dot apply. Okay, apply is the method through which you can supply the argument. So let me, I will go and I will supply test, right? I will supply the test, and this I will write in a print line. Okay, let's see that what is the output you will get. See, test run. So the test, whatever you have written, this arguments, whatever you supply in the apply method, it got supplied here, it got converted to uppercase, and then there was a concatenation. So all your functions got executed and you got the output as an test RAM, right? Clear? You got how to write a functions which will do uppercase and then it will do the concatenations. Let me see some more functions here so that you will get a much more confidence. So it's a simple functions where what it will do, it will give you dot length, right? So why this is giving a compile time error? If you try to see that this is giving a compile time error, the reason being is, if you look at this function, your first line is the input to the functions and your next line is the output from the functions. So length, what is the return type of this length? It is a type integer, so you cannot write here string, you have to write here integer. Okay, you can write here integer, and let me test that. Can I write same thing? Yes, apply, and then again if I will call this, you can see that this is nothing but the length of your string, right? Let me write a third functions. I'll make sure that you will understand everything. So this is my third functions, where what I will do, I'll write on this function, I will check for contains, and let's say I will write test. Okay, but what is the contains return type, guys? Contains return type is the boolean. So you know that in your function, your first argument is the type of input you are supplying to the functions. Your second argument is the return type from the function, so this should be of type boolean. Okay, and the error will go off. You can see that there is no error. Can I test these functions? Yes. Let me write here. Okay, and let me run this program. So this time I should get this as a true. What happens when I supply test 1 2 3? Will this give me true? Let's see that. So this is also true because it is checking for contains. You know that contains, whenever it matches, it will give you the true. But what happens when I do 1 2 3? What will happen this time? This time we should get false. You are getting that false. So you understood like how you can write a different functions, okay, and you can design the functions like this. The benefit is, now you try to correlate with your project. When you get any requirement, so basically what is the requirement? Your requirement is nothing but the lines of multiple lines of logic for any feature. When we deliver, the feature is nothing but multiple lines of logic. So can't we write the multiple line in the function in a file, and whoever wants to call that, he can just make the object of that function, and he can the object of that class, and he can call the function based on his requirement. That's where this functional interface will help you a lot. Now the second thing is, it also saves number of lines. It is more readable. You can see that, see, all are one line, so it is very readable, right? Let's say if I have to write a logic also, let me do one thing. Let me write one logic here, where what I'm trying to do is, I am trying to put some logic. So let's say I will accept integer data, okay, and I will accept the integer data, and I will check for if this guy greater than 10, right? Then return boolean, and I can test this. I can write 100, as well as I can write 10. Why I am getting compile time? Because I need to change the reference, because my functions are very smart. By supplying the input itself, it will identify which functions need to be called. So look at here, it is true and false, because when it is a 100, yes, it is true, but when it is 10, it is false, because that's how you have written the functions, right? So till now we are clear. Let's say you have a one requirement where you need to test whatever number you are getting is a prime number or not, let's say. So how do you write a function for that? My input type is an integer. Now return type is also going to be integer, and I need to test whether it is a prime number or not. Can't I do like this? Modulus by 2. Okay, see, I can just write one functions like this, and if I have to test any number whether it is prime or not, what I can do, I can just go and I can call these functions, right? In 5 I can call dot apply 10, and then I can also call 11. So here I should get 0, here I should get 1 when we do a modulus, right? So you can see that 0 and 1. So for 10 you are getting that 0, for 11 you are getting that 1, because that's how the modulus works. So when you do a modulus, whatever remaining you have, that is nothing but modulus, right? So you have written now, that is performing, that is checking whether the number is prime or not, and now based on that you can write a logic in your program, right? So I have given you fair idea of how to write the function and how these functions will be tested and how the apply method is getting called. Now in the next video I will also show you what are the other remaining method we have this functional interface. So we have seen that apply, okay, we need to see compose and then an identity. Thank you guys, thank you for watching this.